Hey, welcome back, students. We're moving on to section 9.2. We're going to start with multiplying and then we're going to move into factoring. I know that we just finished a unit on exponents, so remember when you multiply exponents, multiply with common bases with the exponents, you add them, and if you have a parentheses, you would multiply into the exponents, and if we're dividing with the same base and exponents, we subtract, and then the last one's adding. So just a refresher of what we're going to do. Okay, on this page we're going to review multiplying a monomial to a polynomial, and guess what? It's called the distributive property. That's what we're doing. If we look at our first example here, we take the 3 and we distribute it. We do 3 multiplied to x, and then we do 3 multiplied to 2. Don't forget the second one. And 3 multiplied to 2 is 6. We end up with this. It's still a binomial, but now we multiply the 3 into it. So let's practice on this one. So what we're going to do is take the -4 and the y squared and multiply it to each of the 3 terms in this trinomial. Okay, let's look what I did. So I took the -4y squared and I'm going to multiply it to the first term. So -4 multiplied to 5 is -20, and then I add the exponents. So 2y's plus 4y's are 6y's. So I'm going to continue that. So if I continue that, -4y2 times -3y2 gives us positive 12, and then I have a total of 4y's. Here I have -4 times 2 is -8, and my y squared stays. It says simplify. That means combine any like terms you have and I don't, and we like it in descending order, which I do have, y6, y4, y2. So perfect, this is ready. Here we go. Alright, so I'm going to take the 4b, I'm going to multiply it to the 5b squared, to the b, and to the 6. It'll look like this. Right here, 4 times 5 is 20, and b1 times b2 is b3. Now I get 4b times b, that gives me 4b squared. Lastly, 4b multiplied to 6 gives me 24b. There's my answer. It's in descending order, and it's good. Alright, on this next one, I'm going to take the -7h, I'm going to distribute it. Notice I did keep, change, just to remind myself that we do have negatives here. Alright, let's start distributing. Okay, -7h multiplied to 3h squared is -21. So -7 times 3 is 21, -21. And h1 times h2 is h3. Alright, here I have -7h multiplied to -8h. So two negatives make a positive, and I have two h's, so h squared. Lastly, I have -7h multiplied to a -1. Two negatives make a positive. I have positive 7h. Alright, what I like to do, hit pause. How about you try and solve this one yourself and see if you get the answer I get. Okay, hit pause and do that. Go. Okay, did you get 2x to the third minus 12x squared plus 10x? Hopefully you did. If you did, you're right on track. You're doing great. Alright, we just did multiplying. Now what we're going to do is called factoring. What's going to happen is we're going to undo the things that we did earlier in this lesson. We'll start with, just remember what prime factors are. So let's list all the prime factors of 18. It's the factor tree, if you remember. So we have 2, and then we have 3 and 3. Here's the prime factorization of 18. Alright, I want to show you what I did with this trinomial. What I did was, I'm going to find the greatest common factor of these 3 terms. So I took the first term and I factored it out. So we have 2 times 2 and we have 3x's. I wrote them out. The second term is 12x squared. So I have 2 times 2 is 4, 4 times 3 is 12, and we have 2x's for x squared. The last term is negative, so I have -1, and then I have 2 times 2 times 2 is 8, and 1x. Okay, so I kind of did this step here. I listed all the prime factors of each term. Now I'm on step 2. Identify the factors that they have in common. Well, they all have 2 2's and they all have 1 x in common. So they have to be in each one to be in common. So they each have two 2's and an x, so 2 times 2 is 4, and this simplifies to 4x. So that means the biggest number that can divide each of these terms is 4x. Now we're going to simplify. We did simplify, so we did step 3. So 2 times 2 is 4, and we have 4x. So we're going to use this skill on our next slide. Okay, so the greatest common factor between 5v to the 5th and 10v to the 3rd. Now, that prime factorization thing, sometimes you can just say, what's the biggest number that divides 5 and 10? And the biggest number that divides 5 and 10 is 5. Then, as far as the with the exponents and the variables, you always take the smallest amount, and that's what they have in common, the smallest exponent. So the greatest common factor for this first one is 5v to the 3rd. That's the greatest common factor. What I did over here is show if you were to write it out. The prime factorization's right here. 2 times 5 is 10. And so what do they have in common? They have 1 5 in common, but they have 3 v's in common, and that's how I got my answer. Let's try this one. What do 3 and 18 have in common? The only thing that 3 and 18 have in common is 3. Now, this has 2 t's, but this has no t's, so here's our greatest common factor. That's it. It's 3. Let's look at our third polynomial. So, what's the biggest number that can divide 4, 2, and 6? Now, the biggest number that can divide those is 2. Now, let's look at the variable. What variable do they have in common? Well, they all have a b, and the smallest amount is 1b. So that's going to be our greatest common factor. Again, what I'll do is I'll show you how you can write it out if that helps you see it better. Here's what I did. I took 4b to the 3rd, and I wrote 2 times 2, and I wrote 3b's. Then I took negative 2b squared, and I took negative 1 times 2 is negative 2, and I have 2b's. Then I took negative 6, I broke it down, that's a negative 1 times the 2 times the 3, that gives me negative 6, I have 1b. Now, what do they have in common? Well, look, they have 1, 2 in common, and they only have 1b in common, and that's how I came up with 2b as my greatest common factor. Alright, so remember earlier we showed how we did distributive property? We're going to do basically the reverse of distributive property. It's called factoring. Here's how you factor. You look at your polynomial, and this is a trinomial, and you say, what number can divide 3, 12, and 15? Okay, we're going to find the greatest common factor, and the biggest number that can divide all of those is 3. Then you say to yourself, what variable do they have in common? They all have x, and what's the smallest amount of x they have in common? Well, they only have 1 x in common. So 3x is my greatest common factor. It's what we practiced on the last couple slides. Now remember, when we were doing distributive property, we were taking a product and making it a sum. Now we're going to do the opposite. We're going to take a sum and we're going to make it back into a product. So here's how you do it. Okay, what you're going to do is you're going to divide each of these terms by 3x. Basically, you're pulling that 3x back out. So, go ahead. What's 3x to the 3rd divided by 3x? And that would be 3 divided by 3 is 1. And then you would have 2 x's left over. Because remember our last unit? 3 x's on top, 1 on bottom, 2 left over. Okay? On this one, negative 12 divided by 3 is negative 4. You have 2 x's on top, 1 on bottom, so you have 1 x left over. Lastly, 15x divided by 3x. 15 divided by 3 is 5, and the x's cancel out. All right, here's our answer. We factored this. So what we did, once again, we took a sum, an addition problem, and we made it a product, a multiplication problem. And how could you see if you're right? Well, you could multiply this and distribute a property back in, and you would get this. But we don't want to do that. We want to leave our answer just like this. All right, here's a few to try. So start off by identifying the greatest common factor. What's the biggest number that can divide 8 and 12? Well, that would be 4. And then, what variable do they have in common? Well, they each have an x, and what's the smallest amount that they have? And that would be 1x. Now we're going to divide or factor that 4x out of these terms to get it out of that. So we'll divide and we'll write what's left over here. So here we go. 8 divided by 4 is 2. You have 2 x's on top, 1x on bottom. You have 1 x left over. Okay, let's do this again. Negative 12 divided by 4 is negative 3. These x's cancel, so we do not write them. Here's our answer. And once again, if you want to see if you're right, you could multiply back in and you will get this. All right, we took a sum and made it a product. All right, our last example on this page. Let's look. What's the greatest common factor? What's the biggest number that can divide 6, 12, and 24? The biggest number that could divide those is going to be 6. That's the biggest number that could divide those. Now let's look at our variables. Well, they all have m's, and the smallest amount of m's is right here, so we can only factor 1 m out of each of them. Okay, once again, I'm going to divide or factor out the 6m from each term of this trinomial, and I'll write what's left right here. So we have 6 divided by 6 is 1, and we have 3 m's on top and 1 m on bottom. That gives us 2 m's left over. Okay, so I have negative 12m, so negative 12 divided by 6 is negative 2. I have 2 m's on top and 1 m on bottom. I have 1 m left over. My last term, negative 24 divided by 6 is negative 4. These 2 m's cancel, so they're gone. Here's my answer. If I were to distribute that 6m back, guess what? I would get the question again. All right, students, here you go. So I want you to practice distributive property again, and especially when we have exponents that we have to add. Okay, on this one, distribute, and then make sure you do keep change, then distribute the negative 5y. Careful with your negatives. Here, just name the greatest common factor. And here, practice what we did called factoring, where you divide out the greatest common factor. Good luck. Bring any questions you have to class next time we meet, and take care.